Hi, welcome to Science Chomp. Today we're going to be looking at the concave mirror. Now, a concave mirror is a mirror shaped like this. There's a couple of things that you need to know about this. First of all, there is this axis here, this line down the middle. You can call this the principal axis or the optical axis. It's the same thing. So it's a line which runs right down the middle of the mirror itself. The other thing is we've got this thing called F. F is the focal point. So whenever a light ray is going parallel to the optical axis, it will bounce off the mirror and it will converge onto the point labeled F. So that's the focal point. That's F. There is another one here called C. Now C is double the distance of F. You see this distance here between the mirror and the focal point. That's the focal length. That's F. Okay? 2F is where C is. So sometimes people call it 2F. Other times they call it C. The reason why they call it C is if this was a giant circle, C would be in the center of the circle. And it is always double the distance of F, if that makes any sense. So the focal length times it by 2, you're going to get 2F. There are two things that we got to know about the light rays. First of all, if a light ray is along the optical axis or parallel to the optical axis, it's always going to bounce off the mirror and go to the focal point. Secondly, if a ray of light is coming at an angle which is kind of through the focal point, it's going to be reflected parallel to the optical axis. So these are the two things. I'll repeat that again. If a ray of light is parallel to the optical axis, it's going to be reflected through the focal point. And if a ray of light is coming from the focal point itself, it's going to be reflected parallel to the optical axis. Okay, so let's have a look at how we get an image from a concave mirror. Depending on where you have your object, so this is my object over here, it's going to massively change how you get an image. So let's have a look at the first one. We've got an object over here, and it's beyond 2F. So how do we draw this? First of all, we need two rays of light coming from the top of the arrow, and where they cross is where we draw the top of the arrow. So let's try that. Firstly, let's get this thing. This is going to allow me to draw my parallel line. I just got to line it up, right? So this is going to be exactly 90 degrees to the optical axis. I'm going to draw this line in blue. Oh, moved. And just continue that line all the way through to the mirror. Okay, like that. And anything which is parallel to the optical axis is reflected through the focal point. Give it some arrows, like that. Okay? You can see my accuracy isn't great. I'm using a thick pen, but hopefully you're going to get the general idea. And the other line, the next line, let's put it through the optical axis itself. And let's give it a different color. Let's make it green. So it goes through the optical axis, and it's going to be reflected parallel to the optical axis. like that. Okay? And where the two things cross, two beams of light cross, is where you draw the top of the image. So it's like that. Okay? Now, as you can see, we can make some observations about this image. Okay, so number one, it's smaller. Okay. Number two, it's upside down. We can also say inverted. That's a fancy way of saying upside down. And we can also say that it's in between F and 2F. So that's the location. Okay. And we can also say that it is a real image. Okay. The reason why we say it's a real image is because it's made out of real light rays. Okay. So if I was to give the actual properties of the image, usually I would just pick this one, and this one as my three properties of the image. Okay. Now, as we move it along to different points, you're going to get different types of images. So let's have a look at the types of images that we're going to get. Now we're dealing with an object which is within the focal length of the mirror. Okay, so first up, what you've got to do is you've got to do a parallel line. So it's parallel to the optical axis. So the way I try to do it is like this. Okay, you put your set square against the line like so, and then you just slide it across. Now, just make sure that you can move it back to the original position and it's lined up, because you don't want your ruler to move. All right, there we are. So that's going to be my parallel line. I'm going to give it a blue thing here. Now, remember, whenever a ray of light is parallel to the optical axis, it is reflected through the, let me use a clear ruler so that you'll be able to see. It gets reflected through the focal point at this angle, okay? All the way down there. The next ray of light is going to be coming from this angle, so it's from the focal point at that angle. Like this. Okay? Now, let me show where this is coming from. So it's a little bit like that. So it's coming from here to that, but kind of through this angle. Okay? Now, as it's going through the focal point, it is reflected parallel to the optical axis. So let's get this parallel line all sorted again. Again, I like to use this method. You can measure out the angles yourself if you wanted to, but I find this works for me. Okay, so I'm going to hold this ruler really still, and I'm just going to slide it across up here like that. Move it back down to make sure it hasn't moved, and it seems pretty parallel to me. Okay, and it's reflected at that angle like this. Of course, you can extend it all the way through. Now, the whole point about making an image is that the rays of light need to cross. Okay, now of course they're not gonna, because they are diverging out here, it's not going to cross over here, it's actually going to cross behind. So I need to extend both this reflected ray and this reflected ray behind the mirror. So I'm going to do that using these things. And I'm making a dotted line because these are not rays of light now. This is basically a virtual ray. It doesn't actually exist in real life. Although we do perceive it, it's kind of like an illusion. Just make sure that's lined up. The more accurate you are, the better. So make sure whenever you do these, you're very accurate. And can you see where it crosses over? That's the top of that image over there. So then we get our set square. Make sure it's vertical. Like so, and carefully draw that line from here downwards like this. Now, as you can see, this is a much bigger image than this. It's also a virtual image because it's made out of fake light rays. These light rays don't exist in real life. Okay. Number 2, you'd say it's bigger. Okay. And number 3, you would say it is upright. So those are the properties of that image, when you're using a concave mirror with an object in between or within the focal length of the actual mirror. Okay? Let's have a look at a couple more examples. I'll use the computer because, as you can see, my drawings aren't the best. Okay, so here are 2 more ray diagrams for concave mirrors. Here, the object is located exactly at 2F. So here they've got it labeled as C. I call it 2F. So it's exactly at 2F. And as you can see, where the image forms of the top of that arrow is exactly beneath it. So what we are getting is an inverted image that is the same size. And because it's made out of real light rays, it is a real image. Over here we have an object which is between F and 2F, and what happens is it produces an inverted image, that's an image that is upside down, that is larger than the original object. It also happens to be beyond 2F in terms of location, and again it is a real image because it's made from real light rays. And here is a ray image, a ray diagram for an object located at F with a concave mirror. And what's happening is you don't form an image because the ray of light going parallel is bouncing through the focal point, and another ray of light, the way it reflects is going to be completely parallel to that line. And parallel rays, they never meet, so it doesn't form an image. Okay, I hope that makes sense. Thank you very much for watching, and I'll see you in the next video. Goodbye.